What are expansion tanks? Why do we need them? What types are out there? Well, Bell & Gossett makes a whole bunch of different types of tanks. The first one we're going to look at is a plain steel tank. It's ASME. It's a steel tank. It's been around for a long, long time, and actually the sizes can get bigger than this, but these are probably the practical standard sizes. We also have a Series D diaphragm type tank. Again, this would be a pre-charged diaphragm from the factory, 12 pounds, but we pre-charge these so we cannot lose the air charge. The difference in the two is in the plain steel tank, the water is in contact with the air. The water is in direct contact with the air. There's no membrane. The Series D diaphragm tanks, and as we've seen on the next slide, the bladder tanks, the water is actually protected from the air by a membrane. In other words, you have a membrane that we pre-charge with air, so the water is not directly in contact with the air in the expansion tank. It is in contact with the air in the system, and we're trying to control the system air, but it's not in contact inside of the expansion tank with the air, because that's a bladder there, like a big football bladder, that we pre-charge to make sure we have an air cushion. So that's the major difference. And the Series B is the full bladder type of tank, and we'll talk about them more later on, where we can actually get full acceptance volume of the tank. In other words, if we had a 53-gallon tank, we could start off with 53 gallons of air in the cushion. That would be the acceptance volume available. So we'll take a little bit closer look at these as we go, and we're going to talk about them and why we need them. Here's another picture of a standard expansion tank, steel tank, water in contact with the air. The way we did it for years and years and years worked quite well. Today's marketplace, I would suspect this is probably 10% of the market or less, and the diaphragm bladder type tanks are probably 90% plus of what we see. But you're going to see these, particularly on older jobs. You need at least to understand they work and how they work. First of all, if you have an old type standard steel expansion tank or compression tank with water in contact with the air, a lot of the old timers wanted sight glasses on the side. And one straightforward statement to you would be to please valve off the top sight glass so the cork or the material or gasket material doesn't get dry, because it's a source of leaks. And just note and think about this. If this is under pressure and you get a leak at the top sight glass, your tank's going to become waterlogged. It's a very common problem, but I think you see what's going on here. If we had a leak at that top sight glass and the system's under pressure, air is going to leak out and the water's going to fill up in that expansion tank until we get a waterlogged tank. Also, in the old-fashioned or the way we were brought up, standard tanks, water in contact with the air, we used air-controlled tank fittings. And this is a typical one that we have used before, called an ATF. This prevents gravity circulation between the tank and the system. It also helps establish the correct water level when you start the system up cold. Real quick comment would be, it keeps the water temperature in the tank at ambient temperature, and your water in the boiler could be 160 to 180. So that kind of gives you a reason for doing this. It, in essence, gives you a smaller tank because of the air-controlled tank fitting. It helps you start it up and get all the air out to begin with and have the proper water charge inside your tank. I think one other side comment here you should recognize in a regular tank. This tank is not full of air at startup. Once you get it started and get the pressures on it, it's going to be partially full of water depending upon the makeup pressure when you start it off. In other words, the acceptance volume in this tank is not going to be 100%. It's going to have some portion of it full of water when you start the expansion process. In other words, you fill your system up with water. The tank is sitting at 0 psig when you start it off, and you start adding water in it, so you've got an air cushion, but that air cushion is going to be under pressure. It's going to compress somewhat, and you don't have a tank that's 100% acceptance volume. That's why bladder tanks, properly charged, can physically be smaller. One other quick comment on this. This air-controlled tank fitting needs to be above the air separator so we can have the air moving back and forth by gravity, by just rising air. So here's some pictures again of the pressurized bladder tanks. The one on the left would be a full bladder. You can replace it. You can have 100% acceptance volume of air in the bladder tank if you have it properly recharged when you start off. The diaphragm tank on the right, you cannot replace the bladders. It just has small tanks inside it. It's a throwaway tank.